Hello everyone and welcome to yet another recreational programming session with Mr. Azozin. So Freya, I think a year ago, posted a very interesting video talking about whether you can actually distinguish 60 FPS, 30 FPS, 120 FPS, and so on and so forth. Right, so I'm going to put the link to this tweet in the description for people in the chat. You can actually do today command and it will give the link to the tweet. Right, so let's take a look at the video. So what she did is actually rendered animation at different FPSs, but also rendered subframes. Right, so let's take a look at that. So look at that. So this is different FPSs, and her point was that you can definitely see the difference between different FPSs. But here's an interesting thing. How do you do that? And this is how you do that, right? So essentially, and a lot of people accuse her in the replies of deceiving or something like that, but I don't think it is deceiving. It's sort of like an approximation how your eye will actually see the differences, right? So what she did is that for a single frame, she did a simulation for the target FPS and rendered the subframes. So which created kind of a blur effect, but that blur effect actually worked really, really well. Right, so, and one of the things I want you to do, I want you to actually implement that and see how easy or difficult it is to implement, and maybe even integrate it to Panim, right? So we'll see. I'm not really sure about Panim, but I really want you to try that. So the thing is here is that people absolutely hate like a motion blur in video games. And I don't really know why, because I don't really play video games and I never really played a video game with a motion blur, right? So I kind of stopped playing video games, I think around 2014, right? So when I started to actually, when I moved to a different city and stuff like that, I didn't really have time to actually play video games at all. So, and my hypothesis why people like hate this kind of interpolation and stuff like that is because FPS in a game is not just an animation. It is also latency of the input, because you kind of pull the input on each and individual frame, and the more FPS you have, the more often you kind of pull the input, right? So the more responsive it feels. And when you have a lower FPS, you have a more latency in the input, but then the visual part tries to extrapolate all of that stuff, and it looks more FPS than it actually feels. There's some sort of a disconnect, right, between these things. This is my hypothesis. I need to actually try to play with the motion blur to understand like what exactly is the problem here, but people absolutely hate it. So for post-processing, it actually works fine, right? But I suppose for video games, it doesn't really work that well, right? But maybe I don't know what I'm talking about. Like I'm literally talking out of my ass right now, right? So, but anyway, so I think this is a very cool exercise to actually implement. We can actually step by frames, right? So this is the initial animation, right? So the next frame, we can clearly see how all of that stuff goes. And I suppose the way you just do that, you simulate a frame, right? So you render a frame, and that frame lasts longer than your target FPS. So you split that frame into smaller frames, into the target frames, and you simulate and you sort of render several frames, and maybe you combine them together. In the case of a circle, it's actually pretty easy. You just draw n circles in here in a single frame. Right, you just draw several circles in there. Right, for something more complicated where you don't control all different objects and where they go, I wonder if you can like literally save frames in a frame buffer and just overlay them on top of each other with different alphas, which will also probably create some sort of like a motion blur effect. We can experiment with that as well, right? Because this is exactly the situation we have in Panim, because the engine itself doesn't really know what kind of objects you render on a screen. It can only ask you to render something on the screen and then save it as an image, right? So, and I want to add this kind of thing on the level of an engine, not specific animation, right? Something like that. So, sounds interesting, right? So I wanted to implement that like a year ago, right away after I saw this tweet, but I only came to that only now, right? So I have a lot of things in to-do list, right? So, yeah. So let's go ahead and try to do that and see how we can even do all of that. Right, so the usual thing we're going to be using Radip, right? So because it's super convenient, absolutely super convenient. Right, so it's going to be main, like so, and let me do all of that stuff. What was the last project I was working on? Yeah, I can actually steal some stuff from Panim. I think that's the easiest thing to do in here. So I'm gonna be stealing, I do be stealing knob.h, right? So here's the knob.h, and I'm also gonna be stealing the Raylib, right? So I'm going to be stealing it recursively. There we go. So that's pretty cool. So let's go ahead and create knob.c, which is going to be building all of that stuff. And I'm going to just include knob.h. So in think motion blur is the same as high FPS effect. Motion blur should be the equivalent of long exposure in photography. So showing n previous frame of an animation every frame, right? I suppose, maybe that's how it works. I'm using motion blur kind of like interchangeably with subframes because it kind of creates a blurry effect, but maybe I'm wrong. I feel like I'm using the word motion blur incorrectly, so I don't really have any particularly strong opinion on that. So right, I'm just saying motion blur, but I don't really understand what I'm saying. That's what I'm trying to say. So, and also keep in mind that I'm not a game developer, right? So I'm not really that familiar with terminology. So what I did, I just saw a cool thing that I feel I can code, and I just want to code that for the sake of recreational programming. So I really apologize, right? Especially to game developers who know all of that shit. Again, I'm just a stupid Java enterprise developer, right? So I don't know shit. Motion blur is smooth in frame-to-frame pixels. Nobody likes it. Oh, it's on the level of pixels. Right, so in here, I feel like in this particular animation, it's on the level of like literally objects. And this is what I will try to do first, right? So do that on a level of object. One person, holy shit, we've got a raid. What the fuck? Thank you so much. Thank you so much for one raider. Yo, hello raiders. What's up? I'm gonna become famous. Yo! All right, so can I steal some building stuff from Panim? In Panim, I actually have a pretty cool thing. I have a function that just builds an executable. And I feel like maybe, like I keep writing that thing over and over again to the point that maybe I should include it into the knob itself, right? So essentially here I do build xz, then I accept the CMD into which I'm going to be pushing the commands and then inputs and outputs, right? And it just does the thing. It also checks for whether you need to rebuild the exe or not. So it feels really convenient, honestly. It feels really convenient. So I think I'm going to steal that. All right, so I'm going to put it like this. So, and it uses a couple of other things, right? So let's actually try to build knob.c and see what kind of things it's asking for. Yeah, it's asking for functions like cc, and cc actually adds the current compiler, right? So there we go. So essentially it just basically adds the compiler and also C flags, right? It's all common flags between the builds and stuff like that. So, and I put it into a separate function so I can easily change what kind of compiler to use, like GCC, or maybe I'm gonna change it to Clang or something like that, right? So so usually these kind of like a common flags and common parameters are stored within variables in different build systems like CMake or makefiles or config and stuff like that. I store them as a code, as function. This is sort of like an innovation that I'm using in Knob. Instead of storing these parameters in variables, right, and then concatenating those variables and adding them to command line, I'm actually storing them as functions that append those parameters, those flags, to your current command line. And it's actually kind of convenient, at least in the C setting, right? So if you're using C as a build script, it is actually kind of convenient because on top of just storing the list of the arguments, you can also store some logic. Who said you can't accept some sort of a flag? And depending on that flag, you can actually push different things, and you can have a complicated logic in the reusable list of the command line arguments. You can actually get really creative with this kind of stuff. It's kind of cool, honestly. It's kind of cool if you think about it, right? So, yeah. So that's what we have in here. Let me try to rebuild this entire thing. And so what else do we have? So C flags. So it says that I just added the flag. Right. I just added the flag, that's totally fine. We don't really need the flag. And the other thing, I need the libs, which is the same thing, right? So it's literally the same thing, it just adds the libraries, right? So it adds the array lib, right, and the paths, and what other libraries you want to link with, like a math library, DL, pthread, and so on and so forth. So this is from Panim. In Panim, though, we are linking dynamically, right? Because we need hot reloading and stuff like that. I don't think we need dynamic linking in here. So I'm gonna actually remove this kind of thing, right? So I'm gonna remove our path, and in here I'm gonna link only with A statically, right? So we're linking only with A. All right, so let me actually try to build this entire thing, and that seems to be building. So honestly, I forgot a very important thing. I forgot to enable rebuild, right? So let's enable rebuild of the script. So that thing will automatically rebuild knob executable every time I modify it. Right, and after that, let's just call this specific function, right? So let's just call this specific function. So what does it want? It wants the CMD, right? So let's accept CMD. So it also accepts a very interesting flag, which is force, right? So the thing about this function that I implemented in Panim is that it only rebuilds the executable if one of the inputs were modified. Right, it uses special knob function to check whether something was modified, and it only rebuilds that. But sometimes you want to force the rebuild. Right, you want to force the rebuild, and because of that, I accept this like a Boolean force. Right, so, and how can you actually get this kind of stuff? So you can actually wire up the force into command line arguments, right? So essentially you can have something like a force equal to false, and then you can parse command line arguments and see if the user passed like -f, and if the user passed -f, you set the force to true, and that force rebuilds everything, something like that. So what does the tweet say? I cannot access Twitter. You can actually access Twitter through xcancel, which I'm pretty sure it's you who told me about that. Right. So yeah, you can do that. It's actually like the name is super convenient. Whoever came up with the name is actually genius. So you have x.com, right? You have an x.com link. And essentially, what you can do, you just add cancel at the end of X, and it just basically unlocks it. It's behaving weird on some tweets. So it's fine for this tweet, but it doesn't really load the video. It doesn't really load the video, so that's kind of the problem. But the video actually looks like this. And I wonder if I can upload it somewhere. I wonder if I can, yeah. So this is how the video looks like. So, and what this video is doing is just like interpolates you know, with subframes, right? So for a single frame, it actually renders several frames and composes them together, which creates, you know, a pretty cool effect, right? So that's basically what it is. Nothing particularly special, nothing particularly special. Anyway, so we can wire force into the command line arguments. So let's actually do knob shift args, argc, argv. The first argument is always program name. So this is going to be just a program name. We don't really need it right now, but I think it makes sense to actually do it first in here. And if argc is greater than 0, right, maybe while it is greater than 0, we are going to maybe take a look at the flag that we got in here. So let's take this thing and put it in here. And if the flag is actually equal to something like -f, we're going to simply set force to true. Otherwise, maybe we can complain about an unknown flag, right? So knob error, something like that. Unknown flag s, and this is going to be just a flag. There we go. And after that, we can actually return -1. So essentially now we hooked it up to the command line argument. So now if you do knob -f, right, in the, you know, in the terminal, it's going to rebuild regardless of whether inputs were modified or not. So it doesn't really matter anymore. So furthermore, like we need to have some sort of inputs, right? So let's actually have input paths. And for now, we only have one input path, which is like main.c, but maybe in the future we're gonna have more. We'll see, we'll see. So, and now I'm gonna be just passing those things in here, and we also need to specify how many of them we have. Knob array length, right? So we're gonna just take the length of this parameter, and the output is going to be, I suppose, I don't know, subframes. Let's just call it subframes. And this thing may fail, right? So if it returned false, we're gonna just return non-zero execute. There you go. So if we're gonna have like more executables, I can just do this thing several times, right? So, and that should work. And by the way, I have to actually give it as a parameter in here. That's it. That's literally it, actually. That is literally it. Okay, so let's try to rebuild this entire thing. And what does it say? So passing build incompatible pointer. This is not supposed to be a pointer. All right, so that seems to be working. So now if I try to build this entire thing, it is building, right? So we have subframes and stuff like that. And if I try to run it, I suppose it's not going to print anything because there's nothing in there. There we go, but it doesn't really matter. So now we can actually try to include RayLeap, right? So, and that I think will go into work, right? So let's do knob subframes, and that actually works. Okay, so let's init window, subframes. And this is going to be 800 by 600, like so. And while window should close, while window should not close, we're going to do begin drawing, and then end drawing, right, end drawing and clear background. And then we have to do close window, but it's not really necessary. I think I'm wasting minutes on that. And there we go. Time. Is that a world record? Do I have a world record for a RayLeap speedrun? I think I do. I think it was like there was actually 20 minutes. I think you can do faster. I think you could do faster. All right. So thank you so much for the sub, everyone who subscribed. So Buni, Mr. Force, Mogwai83, thank you so much. The extra the genius, thank you so much for trying with the message. Your work brings me so much joy. As an enterprise software developer, it refreshes my mind and feels like a delightful escape from work routine. Keep up the fantastic work. It feels like cheating on a wife of 30 years with a joyful mistress. I'm gonna take it as a compliment. Thank you so much. Because this is what programming is supposed to be, right? So that's why, by the way, enterprise is such a, you know, beneficial, how to do that, profitable activity, right? That's literally why, because it was built by passionate people. The passionate people created this profitable industry. And the question is why they were passionate. Because they did the real programming. That's why, right? So what I'm showing you is literally the source of profit of the current industry that a lot of business people are just burning out. They're just burning out. It's a self-cannibalizing process, right? It's a self-cannibalizing process because people were doing like real, meaningful software development. They became passionate about it because it gave them meaning of what they do. Since they were passionate, they created this industry, which is extremely profitable. Then business people came in, started to suck on all of that industry, draining out all of the passion. And when there's no passionate people left, it all dies out. It's a self-cannibalizing process. And to not let it all die, that's why I'm doing all of that, right? I'm reminding people why the fuck we're doing that in the first place. Literally. Right. Anyways. So let's continue. All right. So let's maybe do a little bit of a, you know, background. I think you have to do get color, and then we're gonna do so FF 808080 and FF. I think that should be enough. Yeah. So this is basically the thing. But I feel like alpha has to be the last, right? It uses a different order of the bytes for this entire thing. Yeah, there we go. So, and the next thing we're gonna do, we're gonna be probably drawing a circle, right? So we're gonna start with a circle, the same basically the same thing in the video. Do I have to do a ring or a circle? Right, so let's actually try a ring, right? Because the cool thing about the ring, I think Freya actually chose a ring for a reason, because you can kind of see the other ring. Yeah. So I think the ring actually has a very interesting effect, because you can see other ring like behind the front one. I think that's the reason, and that creates kind of an interesting effect. We can actually try both at some point, right? Like just a circle and the ring. Right, but if I remember correctly, Raylib had a ring thingy. So draw, yeah, there we go. So you can literally draw the ring. So let's go ahead and do that. So we're gonna have a center, and how we're gonna be constructing the center. So to be fair, I want to take the center of the screen, right? So maybe at the beginning in here, we're going to do something like W, which is going to be the width of the screen, get screen width, and the same is going to be height. So now we have width and height, and the center is going to be basically half of the width and half of the height. There we go. So the inner radius is rather interesting, right? So I don't really know. Maybe it depends on the radius, like at all. So this is going to be the radius. Let's actually say it's going to be 100. So, and it's more of a like an outer radius, right? So radius, and the inner radius is going to be maybe half of the outer radius, right? So the stat, oh, it's that this kind of thing. Can I just say 0 and 2 pi, indicating that this is going to be a full circle? And I also have to specify the amount of segments. Let's actually say we're going to have 20 and the color is going to be red. Right, so hopefully that will do the trick. And no, it didn't really work. How exactly do you do that? Excuse me, it's not 2 pi. So, but is it 3 pi? Oh, it's a degrees. Oh my, Ray-san. Like, I understand. This is an educational tool. It's created for teaching students and stuff like that. Students learn degrees in school. Okay. But thank you. Like, Ray-san actually, yeah, gave this tool for free, so I have no right to complain about that. So I literally have no right to complain. Yeah, so that doesn't really look smooth. I think we need to have a little bit more segments. Like, how about 100 of them? I think something like 100 is going to, yeah, it works really well. So maybe, let's actually say, it feels kind of weird in the sense that I don't think this is 100, right? If I use draw circle instead, right? If I take a look at the draw circle, where is the draw circle? So this is a draw circle V. And I'm going to put this thing in here, and I'm going to take the center and the radius and the color, which is going to be red, and I take a look at it. Is it going to be the same? I feel like, oh yeah, it is the same. So in my brain, for some reason, I thought about the radius as diameter, right? So it's not a diameter, so that's why it's sort of like twice of this thing. That actually explains it. Okay. That makes a lot of sense. Let's go back into the ring, and let's make it like, I don't know, 20 or something. Yeah, so that's pretty cool. And let's maybe make it move somewhere, right? So this thing is a center. To be fair, right, so we kind of depend on the screen size while computing the position of this thing, which is not particularly a great thing. I think what we have to do instead, we have to use the camera. What I learned throughout using Panim is that in majority of the cases, you really want to just use 2D camera, because it makes it easy to lay out things on the screen, regardless of the, of the current size of the window or anything like that. Just use camera, right? So, so let's actually say that the position originally, right? So this is going to be, let's call it position, and it's going to be literally just 0. So that's the thing we have in here, and let's replace it with the position. But on top of that, why is it keep saying that it's modified? I don't quite understand. Who's modifying my thing? Who's modifying my thing? I don't really know. Anyways, now what do we need to do? We need to have a camera. Yeah, right. So camera 2D. So this is the camera. Stream sniped, yeah, exactly. So ray leap. Let me find the camera. Camera 2D. So we can actually set all of these things to 0, but zoom has to be 1, otherwise you won't be able to see anything, right? So if I just do that, and then I start drawing, and then I do begin camera, I think it's just begin mode 2D, and I specify the camera, right? And then I say end mode 2D. So it would be nice to maybe realign some of these things, because end and begin, they define sort of like blocks, and I think it would be nice to indicate that explicitly. Look, it looks much more nice. Right, so, and now if I try to build this entire thing, right, so it complains about, yeah, you can't see this entire thing, right? You can't see the circle, precisely because the zoom is supposed to be 1, right? So we have to set it to 1. There we go. So you can now see this thing, but it's not centered. So, and as far as I know, to make it centered, right, to make it centered, we have to do an offset. An offset is just basically half of the width and half of the height. Right. So, yeah, there we go. So that's basically it. That's pretty cool. Anyways. What are we going to do? What are we going to do? So we may try to also have a velocity for this entire thing, right? So this is going to be a velocity, and it's not a vector velocity, and it's originally going to be 0, right? So on each frame, we're going to be just modifying this entire thing. So what we need to do, we need to take the velocity, and we have to scale that velocity. We have to scale that velocity by delta time, and the delta time actually here is just the get frame time. So this is the scaled velocity, and then we have to add that scaled velocity to the position and reassign the position back. There we go. Can your C++ do that? In your stinky C++, you have to overload operators. In C, you can just call functions. Anyways. So we have that. But now we need to maybe control this kind of thing, right, somehow. So for instance, we can do that through, you know, WSD, right, through sort of like a WSD. So let's actually quickly implement that. Maybe, so let me see how we can do all of that. I wonder if I can have some sort of an array, right? So some sort of an array where I could associate, okay, key S is going to be moving to the left, and this is going to be a vector, which is well, S is down, right? So that means it's going to decrease or increase Y, sort of speak. So X is going to be 0, but it's going to be increasing Y. So I'm going to actually, like, you know, denote it as an, you know, unit vector. I forgot the name. So W is going to be -1, right? So then A is going to be -1, 0, and D is going to be just 1, 0, right? And in here, this is going to be an array that sort of like maps a key to a particular vector. So, and the question is how exactly we're going to actually do that. So maybe it's going to be a structure called control, and here we're going to have like a key and the vector, sort of speak. So this is going to be a vec, and we can say this is controls. Right, so this is basically the controls we have. We can even make it static and so on and so forth. So, and in here we can essentially just iterate the controls. That is supposed to be an array. Right, so we are iterating the controls for I less than knob array length controls plus I. And what we're going to be doing, we're going to be just like literally checking if user is key pressed, controls I key. If it pressed one of these controls that we put in here, and if the user pressed, we have to add one of the vectors in here. That's what we have to do. Right, so, and we have to set the velocity to 0 before doing accumulations and stuff like that. And we're just going to do vector to add velocity controls I if that key was pressed, vector There we go. And we reassigning that to velocity. So basically, depending on how many things are pressed in here, we're accumulating all of these things. But what's funny is that that makes moving diagonally way too fast. Right, so that makes moving diagonally way too fast. Because of that, we need to normalize this entire thing. So who knows why moving diagonally is going to be too fast? Who knows why? Because diagonal over square is actually the size of the side square root. Pythagorean, yeah, exactly. So I don't have this kind of thing. Is it working? I don't think it's working. Yeah, boy. Oh, fuck, it just closed. I didn't mean to close it, but it closed anyway. So essentially, if you have a square with a side 1, right? So with the side 1, the diagonal is going to be square root of 2, which is more than 1. So if you press left and up simultaneously, it's going to go slightly faster. It's going to go slightly faster. Because of that, we need to normalize the sum vector. So if you take a look at the array math, do you have a normalize? Yeah, you do have normalize, but no, it's not that one. Vector 2 normalize. Okay, that's cool. So that's square root and everything. So we normalize the velocity. Reassigning it back. But we don't really want to use unit vector as the velocity. We want to kind of scale it to something meaningful, right? So let's actually scale it to maybe 100, right? So maybe it would be nice to have like some sort of magical variable that stores all of that, but I digress. So let's actually go through the compilation errors. Knob array length. So it is available in knob. So this is the knob.h, and what else do we have in here? So vector to add is actually available in array math, like so. And what else do we have in here? So this is not a vector, this is just vec. Okay, and that seems to be working, that seems to be working, and it doesn't, oh, it kind of does work. So this is because I'm an idiot. It's not when it's pressed, it's when it's held down. Press is when it's pressed on the current frame, so it doesn't like, constantly polls and confirms that the key is being held, right? So this is not how it works. You have to use is key down. So, but that's fine. That's really easy to fix. Okay, so there we go. So you can actually move around, but it's kind of slow, right? So maybe I can increase the speed, violence, and momentum. Yeah, there we go. So that feels a little bit better. That actually feels a little bit better. And I don't really have a target FPS. I just realized that. So maybe this is something I have to do. Set target FPS. So it's going to be 60 FPS. Maybe it would be better actually. Okay, so the stream is 30 FPS. The stream is 30 FPS. So maybe it makes sense for me to actually render everything in 30 FPS as well. So I can kind of see everything you see, right? So, and we're going to be interpolating things from that reference point, so to speak. Make sense? I think that makes sense. Anyways, right, so this is what we have. Oh my god, is this how you see everything? I'm pretty sure this is how you see everything. Yeah. All right. So I can literally feel that it's actually 30 FPS. But to be fair, I think it has to be a little bit faster. Right, so let's actually see. Maybe it's going to be like a player speed. Player speed. And let's put it in here. So this is a player speed. Maybe 500. I think 500 is going to be actually perfect. Yeah. So that's actually very cool. I want it to be rather fast, so it's sort of like tunnels a little bit. Like when you're playing with the 30 FPS and you're moving very fast, you can see that a little bit of a tunneling effect. So, and this is actually a very convenient thing. This is a very convenient thing to so it's a very good grounds for implementing this frame interpolation, right? Because that tunneling effect is going to be connected with this trailing tail of the subframes, so to speak, right? So that's pretty good. Anyways, so the question is how we're going to be freaking implementing all of that. So we can actually have like a FPS here, which is 30, right? So it's originally 30. Maybe we can even call it like a real FPS. So real FPS. And then we can have something like a target FPS. Target FPS. And let's actually try to render it at 30 FPS and see how it's going to go. So I think that's rather interesting. So the way we're going to be doing all of that, actually, we can simply repeat the updating of the state and the rendering basically several times if you think about it, right? So, and because of that, it probably makes sense to actually move the updating of the state inside of the rendering of all of this. I think it makes a lot of sense to actually do that, like so. So essentially, what we're going to be repeating, we're going to be repeating this part, right? Updating the state and then rendering this thing. But we're going to be actually updating this thing with a smaller delta time, right? So this is the original delta time, right? But we have to split it into smaller parts. Let's call it maybe a real delta time. This is a real delta time. And what we want to have a target delta time, right? So I'm going to just take the real delta time. Not really a real delta time. I'm going to just say that it's going to be 1 over target FPS. And since target FPS is a constant, target delta time might be as well constant, right? So I think it makes sense. So let's say target delta time is going to be 1 over target FPS, like so. Okay, and the question is, how many iterations do we have to do? How many iterations do we have to do? I think we just have to do real delta time divided by target delta time, right? So, and that kind of gives us the amount of things we have to do. Right, because essentially, let's imagine that you have 30 FPS, right? So 1, 2, 3, 4, 1, 2, 3, 4. So that's a single frame at 30 FPS, right? So it's 30 FPS. So, and essentially you have to render at 60 FPS, and because of that, you have to render like once in here, right? So, and like this, and then once another one, right? So this is basically 60 FPS. Right, so because of that, your target delta time is this. So the amount of times you have to repeat this entire thing is this entire delta time divided by this smaller delta time, and that gives you the amount of things in here. Right, I think that's how we approach that. But this is like floating points and stuff like that. Ass and legs. I forgot that I'm streaming on Twitch. Yeah. So I said that, I think I said it multiple times, is that doing programming on Twitch feels like giving like a nuclear physics lecture in a bazaar street. So that's what I keep forgetting about that. Yeah, so it's ass and legs. Yes, it is ass and legs. Felix, thank you so much for Twitch Prime. How many people actually subscribed recently? So Anonymous Gifter, thank you so much. Thank you. Yeah. So, but this is floating points, so there is like problems with divisions and stuff like that. So maybe we're gonna do a different approach. We're gonna have like a variable that initially stores 0, and we're gonna basically keep rendering and adding target delta time until we become greater or equal to the real delta time. So that way we don't really, divide things or anything like that. So yeah, let's go ahead and do that. So maybe here I can introduce like a float t, and maybe I don't even have to do it like that. So I can do for float t equal to 0, and while t is less than real delta time, we keep iterating this thing, but we're going to keep adding target delta time, right? So we add in target delta time, and that obviously kind of assumes that real delta time is evenly divisible by target delta time, right? So, but I think that's a fair assumption to make in here, right? So this is the thing that we have to maintain every time we set the target FPS in here, right? So we want to make sure that the target FPS is also divisible by Well, I mean, yeah, it's also divisible by real FPS. So that's what we want to make sure, but it's not that difficult to do. Anyways, so let me actually do something like this. There we go. Okay, so let's remove this thing and let's just try to run it. It doesn't work in here because, aha, that's very interesting. So do we have to? Yeah, since we don't really modify the position of the camera, I can actually set the position of the camera outside of the simulated frames, right? So I can put that outside of the simulated frames and just like that. So that should be fine, I think. And here we're using delta time. Okay, so this is kind of cool. What we have to do in here, we have to use a real delta time, right? So, and that will basically render several rings in here, right? So it's going to be rendering several of them. So wait, it's not a real delta time. It's a target delta time. I apologize. So let's remove X. This is so fucking cool, honestly. The fuck. Okay. I feel like the ring has to be thinner. Does it feel smooth? Does it feel smooth? I don't freaking know. So let's actually make the ring a little bit thinner. Maybe like a fourth of this entire thing. It's too, well, no. Okay. So let's multiply it maybe by 8. Right. So now this is 30 FPS. Does it feel smoother? Okay. I think I need to dim each frame. Maybe. Right. So maybe that's a good idea. Let's actually give it a try. So essentially, we kind of have natural dimming in here, honestly, because we can just use T as a dimmer, as the alpha, color alpha, and we can say, okay, T over target DT. Actually not. Actually over real DT. So the closer we get to the real DT, the more like bright it becomes, right? So the old frames, they become dimmer and dimmer and dimmer. So let's actually see how it's gonna go. Does it change anything? Nah, it doesn't really feel that. It's like without dimming, I think it was better. Yeah, it dims too fast. Maybe we could try to, let's call it F. So this is going to be F. And what we can do, we can do something like a square. Do you see what I'm doing in here? Right, so we can just use easing function. Yeah, sigmoid, some sort of a sigmoid, honestly. We can use, let's try to use the square. Or maybe even square root. If all of that, none of that kind of works out, I'm gonna just disable the dimming. I think the square root is a little bit better. Yeah, square root is a little bit better. But this is only 60 FPS, guys. This is only 60 FPS. What if we do 120? So target FPS 120. So this is 120. So it would be even cooler maybe with like a speed of 800. RTX on. Okay. 240. What the fuck? It even for me feels actually super smooth right now. All right, and the maximum one, the maximum one. This is so fucking cool. It's very smooth. What the fuck? So what about 1000 speed? Okay, so let's disable the dimming. I feel like dimming doesn't really do much. It kind of like, So without the dimming. Shouldn't you dim dividing by all simulated frames per actual frame? It's much brighter than moving now. Dim dividing by all simulating frame per actual frame. What do you mean dividing by? Oh, I don't understand the question. All right. So let me see. Without dimming, it looks like a sphere. Maybe it does. Anyway, so is there a blur effect? Not explicitly. Maybe he means dimmer the older the frame is. That's literally what I do. Congratulations, you figured it out. That's literally what I do. The older the frame, the dimmer it becomes. Yes. That's how it works right now. That's literally how it works. So yeah. Dim the oldest. That's literally what I'm doing, guys. That's literal. That's dimming the oldest. That's dimming the oldest. Okay, and chat is trolling me already. Dim these nuts. Oh, dim these nuts. Anyways, so it would be kind of cool to maybe actually do several of them. Right. So it would be kind of cool to do several of them. Maybe them interacting with each other in chat. That would be kind of cool. That would be kind of cool. So maybe we could do the, you know, the physics simulation. Right. So yeah, I'll go ahead and do this physics simulation. To be fair, I'm already streaming for 1 hour. Like I barely scratched the surface of this shit, and I already streaming for 1 hour. What the fuck is going on? Did I become such a bad programmer? Maybe, I don't freaking know. I think I'm starting to have a skill issue. But I need to make a small break because I need to make a cup of tea. And after the small break, we're gonna try to put actually several objects in here and try to make them interact with each other and stuff like that. So I'm thinking about like a gravity physics simulation situation. Right, so I think it's gonna be fun. Anyway, so let's make a small break and all right. So we have one circle moving around. So that's what we have. Let me actually try to run this entire thing. There we go. So here's, it's actually kind of cool. Right, so now I want to have several of them. Right, so we probably need to maybe have an array of vectors. We'll need to introduce a dynamic array. So how are we going to be calling all of that? So I'm going to say it's a type def struct vectors. Do I want to say 2? But then it's very easy to confuse this specific type with just vector 2. So usually how I do that, I put s at the end of the name, but it's not grammatically correct. So can I say vector 2s? That's very funny. Like, so vector 2 is a singular form. Plural is vector 2s, obviously. Freaking, yeah, vector 2s is a plural form of it. So vector 2, and this is going to be items, right? So then we're going to have the count, and then we're going to have the capacity, right? So capacity. And essentially, instead of just a single position, we're going to have several positions, which is kind of cool. So to turn this into an array, I can just put s in here and s in here. That's a cool concept for a programming language. So essentially, in C, if you want to denote an array, right? So essentially, you have a bunch of things, right? X and Y, and then you want to say, okay, Y is going to be an array. You have to put like parentheses in here. Imagine if whether something is an array or not was denoted by the ending, like S. So now Y is an array. Sounds like some sort of like a Fortran horror, where if your variable starts with something like I or X or something like that, it is automatically integer, right? So yeah, it has some weird implicit rules that look at the prefix of the variable name, and depending on the prefix of the variable name, it assigns automatically certain type. So, but it's kind of like a discouraged behavior, so you can actually disable this thing. Right, so, but by default it's on, right? So you have to do this implicit none thing. If you ever saw the implicit none thing, something like this, like how do you spell implicit none in Fortran? That basically means disable this old as behavior, default behavior that everyone hates. That's what it basically means. Like, that's why in Fortran you have to constantly put this thing everywhere, because it has a very annoying default behavior that everyone absolutely despises, and you have to explicitly disable that. I suppose maybe like in JavaScript it's something like strict none, but I think a strict none or something like strict, it's not strict none, it's just like something, or use strict, I don't remember. There was something like in JavaScript to make it more strict or something, but I don't program in JavaScript, so I don't really know. Anyways, right. Old languages do be like that all the time. Old languages. Yeah, so use strict, it actually came from Perl, right? It actually came from Perl. Anyways, so to be fair, if I want to be doing a little bit of a physics simulation, what I will need to do, I think, I'll need to bounce off of the edges, but because of the bouncing off of the edges using camera is not particularly convenient, so I'll have to remove the camera. And by the way, I also need to keep track probably of the velocities, right? So this is going to be velocities. So we have that, and there we go. So we're removing the camera, fork the camera. And so within in here, we're not controlling any of this shit anymore, right? So we're not controlling any of that stuff. So what we're going to be doing on each individual frame, we're going to be iterating through the things, through the objects. Honestly, so we have a little bit of like parallel arrays. Is that a good idea? Honestly, I'm not sure. Maybe it is. Maybe it is for like for ease of like vectorization or something like that. It's like I heard that instead of having like array of structures, it's better to have like a separate parallel arrays, right? Because then it's very easy to slap CMD on top of that. So maybe that's basically what we're going to be doing here. So, but I'm not going to be explicitly programming in CMD. So I hope that the compiler will vectorize it for me. So this is positions, and we're going to just assume that position has the same size as the velocities, right? So that's what we have in here. So velocity, we don't really need to scale any of that stuff, I believe. Yeah, so this is going to be just that. Right, and we're going to be taking the position items. So this is the position items I, and we're going to be taking the items I. Right, so we scale the velocity, we add the position, and we have to kind of reassign that thing back, like so. Right, and now we have to use the item's position like so to render that specific position. Okay, so that's basically what we have in here. Honestly, I want to also render those things with different colors, right? Because of that, it would be nice to have something like this, colors. So colors equal to 0, so something like that, and type def struct colors. So and in here we're going to have a color, and then items, size t count, and then the capacity. Size t count and then capacity, and then we can just use the color from this thing. Come on. So colors, items, I. All right. So let's see if this compiles at all. It doesn't seem to be compiled, so that's fine. So because we don't really have a camera anymore, let's get rid of that. Yeah. So it actually became smaller, surprisingly. It actually became smaller. So what else do we have in here? So it's velocities. So we have a little bit of a thing in here. Incompatible type color alpha. Yeah, so this is because you have to put the color first. Yeah, so this is the first color, and then we have to put F in here. Okay, so I did a little bit of fucky-wucky. Okay, that seems to be working. So we have a little bit of a stuff in here. We will probably need W and H soon, right? Because we're gonna be bouncing them off of the edges and stuff like that. But whatever. Okay, so how we're going to be adding the circles. I'm thinking that essentially you're supposed to click all right, supposed to click on the screen and it will add a circle, but the question is like what's going to be the velocity of that thing. For now we can just like pick whatever velocity, right? So and see it, you know, working and moving around. So let's actually quickly do that. So let me see. So what is this thing? Is mouse button, I think is mouse button pressed. I think that's what we want to have in here. Is mouse button pressed? Mouse left button something. Yeah, mouse button left. Right. So this is a mouse button left. Mouse button left, and we can take the mouse position, get mouse position, and just basically add that as the new position. So this is going to be a positions knob. Just a second. Knob di append. So we're just pushing this thing in here. So for the velocities, I think for now we can just add some sort of like a very simple velocity. So this is going to be vector 2. I have to wrap it like that because all of that is macros. And this one is going to be, let's actually make it move to diagonally down, right? Something like this. And in terms of the color, right? So it is going to be, suppose red. Let's just use red. Okay. So now if I press, pew, 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 pew. All right, so that's cool. We can now make them, you know, bounce off of the edges and stuff like that. So that seems to be like a good thing to do. Right, so, but we have to now handle this stuff slightly differently. So we need to do a velocity, right? So a single velocity that we have in here, velocity. And the way we're going to be doing that, so we need to first actually compute the next x, right? Let's call it nx. So this is going to be the positions items x plus, honestly, we probably don't even need to have these variables. We can scale it right away like this. Right, look at that. So we have the new x. Now we need to check whether that new x goes out of bounds, like whether to the left or to the right. Right, so this is what we need to do. But we also have to take into account the radius and stuff like that. So this is going to be nx minus, what is it called? Radius, right? So this is the radius. If this thing is less or equal than 0, or n plus nx plus radius is greater or equal the width, in that case we should actually not sort of use nx as the new position. What we have to do, we have to invert the x component of the velocity. We can actually multiply it by -1. Otherwise we sort of commit the x component of the position like so. So this is the new x, like this. So, and we do that for both of the components in here, right? So we do that for y too. And that actually creates a very simple collision detection, right? So that creates a very simple collision detection. So this is going to be that, but we also should not forget to replace w with h because they are different. And that's about it, honestly. That's about it. So now if I do something like this, it actually starts bouncing off of this thing. And we can actually have several of them. And they are extremely smooth, though it kind of slows down, right? Because we actually have several simulations per frame, so maybe it's gonna, yeah, maybe it's gonna slow down at some point. It's pretty cool. It's actually pretty cool. So FPS, this is 30 FPS, by the way. So for those who like just joined, we're doing that at 30 FPS. All of that is 30 FPS. But it looks too fucking smooth for 30 FPS, isn't it? Doesn't it? Right, because we're doing subframe rendering, and that's kind of the point of the whole thing. Right. So does it look smooth? Right. It's not bad for 30 FPS. What does it look like in 50 FPS? Okay, so let's actually give it a try. So I wonder if it's going to... So we have to actually make sure that real FPS is kind of divisible at target FPS, right? So essentially, we were rendering at 30 FPS, trying to simulate 480 FPS. Think about that, right? So that's why it looks good. Like we're kind of interpolating it. So All right. Oh my god. Oh, well, I mean, there's nothing. Okay. I think at 50 FPS, the illusion starts to fall apart. I think it starts to fall apart, honestly. Like you can clearly see that this is an illusion. 24 cinema standard. Okay, so let's try 24. Actually, 24 is not that bad. Yeah, 24, it's all right. Would make the illusion. Yeah, I think 24 does make the illusion. Okay, so let's actually keep it at 24. Not bad. I think it's not bad. So yeah, anyway, let's actually add something like a gravity. Snap back to reality. So gravity, I think like I remember that the gravity around like 1000 is usually kind of okay for these kind of simulations. And essentially in here, what we're going to be doing, we're going to be updating the velocity first with the gravity. So we have to do gravity multiplied by target delta time, right? So this is a target delta time, and this creates kind of like a new vector in here. And the vector has to move down, right? So it has to be positive. So y goes down, right? So, and this is going to be 0. And so that means effectively we can just add the y component of the velocity, right? So we're just adding the y component of the velocity, like so. All right, so, and it's that easy to just add gravity. So, and what's funny is that there's no loss of energy in the entire system. That's why they're going to be bouncing forever. So as you can see, there's literally no loss in energy. So which language is this? This is C. This is pure C. Man, like with a high, oh my god, this is so fucking cool. This is 24 FPS. Just think about that. Like at 24 FPS, it's just like, oh my god. Yep. Yep. It's mesmerizing. What the fuck? Why is it so fucking mesmerizing? Anyways. All right, what do I want you to do? I wanted them to kind of interact with each other, but it's a little bit difficult, honestly. It's a little bit difficult. So maybe the way we're gonna go about that, we probably gonna separate the loops, right? So first we wanna check the collision for each individual of those things with the wall, right? Then on the next sort of loop, we can check the collision with each other, right? So resolve the collision with each other and stuff like that. Yeah, so and then on the next loop we kind of render everyone. So that's what we can do in here. So yes. Maybe we can do that within this entire loop. So we can actually start another loop, which goes somewhere in here. So this is going to be size tj, but it's going to start with I plus 1, right? So we are colliding the ith ball with everyone else except us, right? So that's why it's I plus 1. So that makes sense. So we're going to do less position count plus j, and that's a very interesting situation. So how are we going to be doing all of that? I suppose we can kind of do this similar thing. Yeah, so we either commit the new position or don't commit the new position. But in case of the, yeah, oh, this is actually kind of cool. Can we actually do it like that? So we can have some sort of a boolean that tells us to commit X or not commit X. Commit X or not. So, and essentially, this entire thing, I can probably move it to here. So commit X like this, and so this is not commit X, right? So we kind of have to like invert it. Maybe it would be even better to do if this just like false instantly regardless of anything, right? If commit X, right, if commit X, we're just committing it, otherwise we don't. So this thing is going to be basically copy pasted from whatever I'm developing here above, so it's going to be totally fine. So, and essentially what we need to do in here, we have to iterate through each individual thing in here and just like test whether the circle with the new position intersects with any of the other circles. You know what I'm talking about? You know what I'm talking about? I think that's a cool idea. So that will basically make it interact with each other. So now I want them to collide with each other. So collision, what was the collision? Check collision circles. That's what I'm talking about, meine Freunde. That's literally what I'm talking about. Yeah. So essentially, if something has collided, we instantly say commit X false. So initially we can say, okay, it is true. All right, it is true. So basically committed. But we can actually derive that commitment from here, right? So if you have this kind of thing and it's false, you commit X, right? So that makes us actually get rid of that. And now if we actually caught any collision with any of the other circles, we do false, and that basically doesn't commit anything in here. Also, we can do something like and commit X, right? Yeah, that's a good idea, actually. I think it's gonna work. So now we need to figure out these centers and stuff like that. So what's gonna be the center one? Center one is essentially, in terms of X, it's a new X, but in terms of Y, it's an old Y, right? So something like this. So this is a center one. So here we just use a regular radius. Center two is basically the center of the jth ball. Jth balls. Right, and the radius 2 is a radius. There we go. So something like this. Yeah, and basically the Y collision is going to be the same thing in here, right? So the Y collision is the same thing in here. So, and since this piece of code actually repeats a lot, maybe I could factor it out to more abstract thing that doesn't really care about specific, but I mean, it's only 2 instances of the same code. It's only 2 instances of the same code. So yeah, let me actually put this kind of stuff in here, and let's do a replacement, a little bit of a replacement. So query replace X, Y. So let's go. And we'll have to also replace W with H, right? So that's basically what we have in here. So this is a horizontal and vertical collisions and stuff like that. Horizontal and vertical stuff. All right, so what do we have in here? And okay, so this is the first thing. Nobody interacting with each other yet, but this is because they're... Oh, fuck. All right. There was some sort of a weird interaction which I didn't... Yeah, so what the fuck was that? Did you see that? Did you see that? This is not... Like, they are not fucking interacting properly. So... so, yeah. Change the center to commit Y. No, this is not how it works, honestly. Okay, so that's bizarre. Oh, shit. Oh, yeah, I see what is going on. Yeah. So it has to be... You're right, you're right. So it's not only like changing the names, it's also changing the semantics, right? Spooky action at the distance, yeah, exactly. So the semantic is slightly different in here as well, right? So... okay, so how about 2 of them? So hopefully that kind of worked. Yeah. They also sometimes stuck with each other, which doesn't really look good, honestly. So we probably need to... Okay, so when there's some sort of an actual collision in here, we need to do a collision resolution, to be fair. So just doing a very dumb thing is not gonna cut it, unfortunately. So there should be some sort of a collision resolution. And that's already a more complicated algorithm, honestly. right? So it has to be something more iterative, in the sense that like we check all of the pairs, we sort of like put them apart a little bit. Commit X is inverted. Is it inverted? I don't really understand. Well, it's kind of intentionally inverted. So if this becomes false, right? Yeah, I think that's fine. Some collisions are working perfectly. Yeah. So maybe it's not a particularly great idea to do it like that. So if we get rid of these things, so the cool thing about this code is that you can just get rid of these for loops, and you effectively got rid of the, checking the collision with each other, right? So you effectively get rid of that, so that works without it. So maybe we're not going to go into that, honestly. I think we're not going to go into that. I think that's totally fine as it is right now. One of the things I would probably like to do is maybe use random colors, right? So using random colors actually sounds nice. I think I'm going to try to do that. But what kind of colors we're going to use in here? Honestly, I was thinking maybe taking a random color from a palette, right? But it's kind of boring. So I think I'm going to use HSL, hue saturation value, saturation value, and I'm going to be basically taking a random hue, right? Hue is a color wheel of from 0 to 360 degrees. And we can just pick a random hue in there, and we can set like a higher saturation and maybe higher value, so it's sort of like a really close to pure color. Right, and any random color in here is going to be probably all right. Not really 100% sure, but yeah, we'll see. So saturation and value should be fixed, but hue could be random, right? So that sounds like a good idea, honestly. Anyway, so let's give it a try. So when we are generating a random thing, so we just set a red, right? So we just set red. So in RayLeap, color HS, so what was the HSV? From HSV. Okay, so this is a good one. Color from HSV. And there should be also some random number generated. Yeah, there we go. So you can get a random number. So, and let's say that the random number is going to be from 0 to 360, and we can set it as a hue. In terms of saturation and value, let's say that the saturation is going to be 1, right? So, and value is going to be something like 8, and that's the random color we are dealing with in here. That's the random color we are dealing with. So let's actually do something like this, and every time this is actually very good. Look at this shit. I think there has to be a little bit less saturated, honestly, like maybe half saturated, right? They have to be bright. Yeah, this is much better. Look at that. They're a little bit dimmed, so that's much better. So you don't want them to be too colorful, because otherwise they will put me in jail for LGBT propaganda. So because I'm currently in Russia, so you have to be careful with this kind of shit. So yeah. All right. So now, what we're gonna do? I also want you to actually do a pretty cool thing. I want you to set the velocity based on the on like where you sort of swipe. You know what I'm talking about? So essentially, I hold down, that adds the thing, right? But it allows you to move this thing around, and then you can just sort of swipe in a certain direction, and it will basically send it there, and that's going to be the initial velocity of the circle. So that's what I wanted initially to do. So yeah, set the velocity. So you can already set the position. You can pick a random color, right? So all of that stuff is randomized, but the velocity is fixed, which kind of sucks. Right, so which kind of sucks. Searching is a foreign engine. Nah, like they're not gonna assign foreign engine to me because I'm too small, and I don't really say things, dangerous things in Russian language, right? So they usually don't care what the fuck you say in English, because I don't know, somebody like No Fuckers actually said a lot of shit about the Russian government in English specifically. Does he have a status of the foreign engine? I don't think so, actually. Because he was saying all of that specifically in English, so they don't give a shit. So, yeah. So the rule of thumb is you can say whatever the fuck you want in a way that the peasants can't understand. Right. You know what I'm talking about? Right. So it's just like, if peasants can't understand whatever the fuck you say, it's fine. Just say whatever the fuck you want. It's just like, yeah. It's the same shit with like a VPN, I think in Russia. So essentially, VPN providers, big VPN providers are banned in Russia. You can't use them. But what you can do, you can buy VPS, right? A foreign VPS. You can install your own VPN there and you can use that, and it's absolutely legal. It is actually kind of like a legal thing to do. So the only thing that is illegal is to provide that as a service for other people. So yeah, like you can do whatever you want, you can read whatever, just don't let the peasants know. Don't fucking let the peasants know. That's the general rule of thumb. A nice loophole. What's funny is that people in China actually told me that they have the same system. So in China, like all of the VPN providers are banned, but you can legally buy VPS outside of China, install your own VPN and use it, and that is legal as well. So it's sort of like a Chinese system. It's kind of interesting. It feels like some sort of like IQ test. It's kind of bizarre actually. Okay. So they allow you to do this kind of stuff, but only if you have a technical knowledge to do that. So it's literally feels like an IQ test of some sort. What I'm drinking, by the way, I'm drinking Earl Grey right now. What's funny is that it's kind of like difficult to ban VPNs completely because VPN was not designed for bypassing limitations. You know what I'm talking about? It was never designed for bypassing limitations. It was for creating virtual private networks. That's what VPN stands for. It's a virtual private networks. So people in Russia, within Russia, actually have legitimate use for this thing, apart from bypassing limitations or anything like that. Like a lot of companies just use VPN to connect their business network and stuff like that. So if you start banning this shit on a level of protocol, you're kind of disrupting the infrastructure. You can't really ban this shit. Right, so you can ban specific VPN providers, right? But the protocol itself, it's kind of like, it's too much. Is diminishing return to stop all VPNs? Maybe this. Can you track the Windows velocity and you move it? I think I can. Actually. It's one of the things I want you to try sometime, actually. So, yeah. Because you have the position of the window. Then on the next frame, the position of the window has changed. Can you take the position of the window? Get window. So window handle. So max size. I can see the position. You can set window position, but what about window position in general? You can get window position. Okay. So you can get the window position. You can keep track of the window position in the previous frame. So that's one of the things you can do. And for example, if the window position changed by some delta, you hard reset the position of the element to that specific delta. So that would make sense if on each interaction with the wall, you would lose a little bit of an energy, if you know what I'm talking about. So because of that, let's actually multiply it by 0.8. Right, so let's multiply it by 0.8, not by 1, or something like that. Yeah, so that will be interesting. So we're losing a little bit of energy every time we are colliding. So as you can see, there is a little bit of energy loss. So that's fine. So at some point, I think it's gonna stop, right? It's also losing energy on horizontally, right? So that's totally fine. Yeah, so that's cool. So, and now we can keep track of the window position on each iteration, so to speak, right? So it's going to be vector 2, win pose, right? So this is going to be something like that. But I'm thinking, so can I get the window position right here? Get window position. So, and then we can say that this is a previous Windows position. So then here we can take the current Windows position. At the end of this entire thing, we can say, okay, previous window position is the current window position. So it's super easy for us now to take the difference between the window positions. So we can do something vector 2, d win pose, right? So it's going to be vector 2, subtract, right? So we're subtracting the window position from the previous Windows position, right? Previous position from the window position, and we get this delta time. And we can, for each thing in here, we can just hard add. So, okay, so here's the position. I modified the position, so I feel like I need to subtract the delta in here. I think the delta has to be subtract. So let's give it a try. So we're going to take the positions, items, and we're going to do vector 2 subtract. So we're subtracting the dwin pose, right? And we're reassigning the position yet again. We're reassigning the position yet again. Okay, so let's let it settle, because only when it settles down is going to be visible if it works or not. I think you have to add it then. Yeet. Fucking yeet, mate. Not normalized the velocity. Gravity. You think gravity has anything to do with all of that? But this is just the position. So I think it has something to do with DPI maybe. So D is affecting velocity. Yeah, it is affecting velocity for some freaking reason. I don't really know why, because we're updating only the position. I would think it's only updating the position. So I need to take a look at what the fuck is it equal to. So trace log is going to be log info, and let's just take a look at what it is. Dwin pose. I could have just maybe drawn. Yeah, let's actually draw it. So draw text. Where is it? So yeah, let me maybe draw it at the end of all of these shenanigans. Let's draw this at the end, and we can do something like a text format. And I'm gonna move this entire thing in there. We don't need that stuff anymore. So it's gonna be x d win pose and this is gonna be 0. Can you see chat? I think you should be able to see chat. So it's gonna be 32, and this one's gonna be white. Right, this one is gonna be white. So this is a very small position. Like, this is such a small thing to modify. Why is it so? Why does it have such a profound effect? Am I being an idiot? Because yeah, so it's just like, it's not supposed to modify it. Delta time, but delta time, delta time has nothing to do with that. Delta time has nothing to do. You add multiple times. You're right. That finally, so somebody actually understands what's going on. Thank you so much. Yeah, we probably have to do that only once, somewhere here. Right, so let's actually do it like that. Yeah, thank you so much. Alrighty, now that thing should be fine. And I actually fucked it up in a sense that I'm adding, but originally I want you to subtract this thing. Originally I want you to subtract it. Okay. All right. Mm-hmm. So there is a little bit of a problem in when we don't have a collision resolution. We don't have a collision resolution that snaps the thing to the side. I think that's one of the things we have to do. We just have to snap it to the side. This is something that we can do in here. So let me try. So I want to get rid of this commit X shenanigans. I don't think this is going to be useful, and let's actually get rid of this entire thing. Right, so let's keep it simple. Let's keep it actually simple. So if we are outside in here, we are inverting this entire thing. We're just inverting. But I feel like in terms of like X, we also have to snap that X somewhere, right? We have to snap that X somewhere. But the place where we're going to snap it to heavily depends on whether we collide it from the left side or right side. So because of that, I feel like we have to maybe separate those things, like so. Else if, like so. Right, so this is the separation we have in here. And on top of that, we're going to always set X to either specifically an X minus radius, right? So that's what we're setting it to. And in here, we're going to be setting it to plus radius, right? And in both of the situations, we are slowing it down, right? So we're slowing it down. So now, what we have to do in here, so let me copy paste this thing one more time. And query replace X with Y as usual. Except this thing is going to be something like that. All right, so I think that's a slightly better situation in here, right? So maybe it is slightly better. So minus, yeah, so it has to be 0. Yeah, you're right. So X has to be, so if it's a left part, right, if it's a left part, we probably have to just do radius, and this one has to be W minus. Yeah, you're right. I can see now. Oh, this is just a radius and H minus radius. That's what we want to have in here. Yeah, boy. All right, so. So it's kind of funny how there's no interpolation when you're moving. Like you can literally see the laggy FPS when you move this thing around. It's kind of funny. Yeah. But there's also no kind of acceleration in here, right? So if like I would like to maybe like somehow accelerate it, but I can't do that. And I wonder if I can. Oh, it actually went away. It's kind of funny. But maybe, oh, they synchronized in here. Yeah. So as you can see, they actually synchronized in position. Oh, this is so funny. So yeah, that's pretty cool. So how can I make the window moving a little bit more smooth? So we need to treat the movement of the window also as the interpolation. Like I don't freaking know how to do that, honestly. I feel like this subtraction of the position has to happen, like it has to be interpolated within the frame, so it creates this trail, so to speak. Add relative velocity before multiplying by 0.8. Relative, nah, I don't think it's a good idea. So the only thing we have in here, we have a lack of the position. So what I'm thinking is we have to be adding position on each iteration, but only by the delta time, not even delta time, but fraction. Yeah, the current fraction of the frame. That's what we have to be doing. Okay, I think I know how to do that. So f is moving from 0 to 1, right, as we interpolate the subframes. It's moving from 0 to 1 as we interpolate the subframes. So we can use that value to sort of incrementally interpolate between these positions, if that makes any sense. But that's... is it going to even work that well? So let me see. So it could be interesting actually if it's going to work. But if we're gonna be, yeah, so I think it makes sense to I think it will work, but I'm not 100% sure. Just let me think. Let me think. So I need real dt. Yeah. So the fraction that we're talking about is more like target dt divided by real dt, right? So because this addition, this subtraction is happening for a single frame, within a single frame. So that means in subframes we have to add it in portions, and the size of a single portion is target dt divided by real dt. So that's what's going on in here, I think. So because of that, I should probably copy paste it in here like this, because I want to preserve the previous code. What we have to do in here is actually scale this entire thing by this thing. This is my hypothesis. I think that's what you have to do to create that effect. I think. So let me try to run it, and it works. It works better than a fucking... holy shit. Chat, do you see this shit? What the... my god. It worked better than a fucking... what the fuck? And I feel like that dt should also modify velocity a little bit. Now we need acceleration when Windows stops moving up. What I'm thinking is that what we have to do, we just have to add a little bit of a velocity in the opposite direction. All right, if you know what I'm talking about. So we have a gravity. Might as well just change the position. So we don't need this thing anymore, that's for sure. So this approach is way better. So this is going to be position, we replace positions, velocities, right? So the position velocities. And so in terms of this one, we're going to be adding or subtracting or something like that. We might as well air resistance drag maybe. Okay, so I feel like we have to add, let's try to add it so it's going to be opposite thing. No, it's incorrect. So subtract. So let's actually let it settle a little bit. Oh, maybe, by the way, what we have to do, we have to actually set it a little bit faster. So what if I put 6 everywhere in here? And honestly, it would be nice to maybe factor out this thing. How do you call this parameter, by the way, chat? What's this parameter that actually dampens, like dampening, I think? So collision dampening or whatnot. I think that's what it is. It's not really friction, collision damping. Yeah, let's call it collision damping. Can we move that out of constant? Yeah, that's exactly what I'm doing right now. and it's gonna be 0.6. It feels like sometimes it just moves way too fast. Like, I feel like when I stop, right, when I stop moving, it should add this velocity in that sort of direction. But what kind of velocity? Yeah, so I think you're right. I think the velocity has to be added. It has to be added, but only when we stop. But what's stopping though? I don't know. All right, I'm gonna leave it as it is. I'm gonna leave it as it is. So, yeah, I'm already streaming for 2 hours. What the fuck? I'm already streaming for 2 hours, so I think I should probably stop already. Yeah. So, dampening. So let's put 8 in here. Relative velocity should work. Yo, that is so fun. And they actually collided like into a single one now. Right. All right. And it's all at 24 FPS, but it feels actually super smooth. Right. So velocity should be in the opposite direction so it stays in place and gets accelerated. Yeah, probably. So what we're just adding, but I feel like it should not be added in steps because we're not trying to create the, but maybe it should be. So what if we also multiply it by like 100? Maybe it's just too, like, not enough. Yeah, so it's definitely not 100. So what about 10? I feel like maybe velocity should be added. Yeah, okay. That's a very interesting point. What if we add this kind of stuff at collision? Right, so yeah, this is a good point. When you are collided with the sides, the delta window position is the additional velocity that is going to, right, so you have a little bit of a dampening, and on top of that, right, you add a little bit of that stuff. So if this thing is 0, you're not gonna add or subtract anything anyway. So Windows transfers energy to the balls. Exactly. And I wonder if I can just directly do something stupid like that. So let's actually try the horizontal one. Okay, so it's subtracting, so that means I probably have to add. This thing. Yeah. Anyway, so I'm already actually kind of wasting a lot of time on this kind of stuff. So it already kind of looks good, right? It's already kind of cool. And I tested out this idea of interpolated frames. So I think I'm going to leave it at that. Right, I think I'm going to leave it at that. So I'm going to upload the source code to GitHub. Maybe I'm going to upload it right now, honestly. So let's actually do it. So I'm going to do license. And you can implement the rest of the cool stuff yourself, right? So yeah, I just show you the idea, then you can evolve that idea into something that you like, right? So you can play with these parameters, you can just add some things and stuff like that. So it's under MIT, do whatever you want, and let's do git init. Right, so this is an empty thing. Might as well git ignore some of these things. So I want to ignore specifically knob and knob old, and maybe also subframes in here, so we don't need that stuff anymore. So this stuff is just like videos that I downloaded. So, and now I'm gonna just do a committee. Ready, set, go. And we need to create a new repo in here. Need to create a new repo. So new subpixel. It's not really subpixel, subframes. Okay. So simple experiment with subframe rendering. And let's create a repository. And all right, so let me copy paste that. And is it where is the okay, so I have to add origin. So here is the origin. And let's push that right into the repo. Let me also add this thing to the chat, so it is available to everyone now. And for the people on YouTube, it's going to be also in the description. Like so. And is it already on? It seems to be already on. All right, there we go. All right, so isn't that progress, chat? I think that's pretty progress. Look at that, look at that. So that's the result of today's stream. It's rendered at 24 FPS. It's rendered at 24 FPS. There is interpolation, and it feels actually kind of cool. So yeah, that's it for today. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all on the next recreation programming session with Mr. Azuzi. Love you. Mwah.